Thank you, everyone, for joining our commonly misunderstood standards webinar for Math K to 5. We're going to give everyone a second, a minute to log in, and we will get started shortly. All right, looks like we are about ready. So once again, thank you, everybody. We have four commonly misunderstood standards webinars. The one today is for math grades K to 5. And my name is Marissa Hooper. I work for Demonstrated Success, and we have a contract with the state, which is why we are able to give you these webinars for free. And so I have here with me today Heather Jenkins
Hello.
and Gray Harrington from the department as well. We have Kristen Crawford on here as well as a point of contact. So her information is at the end for you. So again, we want to thank the New Hampshire Department of Ed. That is why we are able to provide these webinars for you. Just so you know, one of the biggest questions we get is about receiving a PT certificate or resources access to what we're sharing today. That will be sent to you around 24 hours after we end the webinar today. So you will receive an email with a link to the PD certificate, a video of this webinar, as well as the slide deck that we have in here. And lastly, at the end, when you log out, there's going to be a brief survey that pops up at the end of this webinar. We value your feedback, so please let us know what you liked and took away from today's webinar. These are our targets for today, just so you have an overview of sort of what you're going to be leaving with by the end of your hour with us, is that we want to make sure that we understand the progression of the Common Core standards. A lot of us know our grade level standards. We want to make sure we understand the progression across grade levels and how the standards evolve in meaning and complexity. We are definitely going to identify commonly misunderstood math standards, give you some examples and instructional strategies for those specific standards, and then also some strategies to differ instruction. And so we want to make sure that, regardless of the standards that we have identified as commonly misunderstood, how you can sort of take that and take some resources to identify other commonly misunderstood standards that you might have. So we're going to start off with a standards overview today. We are going to shut off our cameras just so you are able to see the full screen, and then I will hand it over to Heather.
Great. Thank you, Marissa. All right. First and foremost, we just wanted to make sure everybody was on the same page when it comes to standards and just a little bit of information about them. Marissa and I are on site quite a bit with folks, and one of the things that we see consistently, and if you're an educator, you know you've probably felt this or before, and either been the brunt of this or somebody who is blaming the previous grades, is that we do a lot of that blaming, like, oh, did kindergarten do what they were supposed to do? First grade, second grade, third grade, fourth grade, whatever it may be. And basically what we're saying is with this is we have this sort of build a bridge is what my husband would say, is that we need to to understand that um, people are teaching what they are supposed to be teaching in their grade levels, and we can't play that blame game anymore. What we need to do is we need to kind of work all together and make sure that we're building sort of those bridges of learning rather than sort of playing that blame game. All right. First and foremost, we are looking specifically at the Common Core state standards. Those are what we follow for the New Hampshire state standards for math. When it comes to the standards K to 8 in general, they are internationally benchmarked. There is guidance in there for the rigor and building that conceptual understanding. We are looking also at procedural and fluency and application of that. We'll talk about this a little bit later. We want to make sure we're focusing on the key concepts at each grade level. There are developmental progressions and learning trajectories that we're going to be talking about, and we want to talk about a little bit of the understanding of making sure that you know what comes before and what's coming after you. There is the way the standards are written is they are sort of like a 3-year cycle of, specific concepts being introduced and then worked on in a specific grade level and then secured in another grade level. So it's really helpful to kind of understand how those concepts progress year over year. Key concepts at each grade level. If we're looking at specifically the K-8, I know we're talking more the K-5, so those first couple, there's really a greater focus on fewer topics. So in the grades K-2, we're looking at concept skills and problem solving related to addition and subtraction. And then in the grades 3 to 5, we're looking at those same things related to multiplication and division of whole numbers and fractions. You can kind of see where it goes into 6th grade and so on. We are going to concentrate just on those K-5 topics today. With looking at the key concepts at each grade level, again, we want to talk about rigor and understanding that there is a specific amount of rigor that is needed to be able to ensure that students are understanding conceptually. We have focused for a lot of years on those procedural skills and that fluency, and we're going to talk a little bit about maybe how to kind of get away from that and build that conceptual understanding so that students are able to do those, have a little bit better fluency and understanding. When we look at these three, the conceptual understanding, it's interesting. That almost is like on the bottom. That's like your base. We need students to be able to conceptually understand why numbers are work the way they are and how all of these concepts work together and build upon one another. We also in that want to build that fluency, just like we would with reading. We're teaching students, your basic concepts of reading and your phonemic awareness and all of that. But if they don't have that fluency, it sort of breaks down a little bit. So we do want them to have fluency. And then we want them to be able to apply the skills in novel situations. So that fluency isn't just the skill and drill, it's being able to apply their understanding of numbers to novel situations. When we're looking at the standard and standards for math, just again, to kind of have you understand how the specific standards are set up. Each particular standard has a what we call a domain or reporting category associated with it. So when we're looking at that, we want to make sure that we understand there are different domains or reporting categories, but then under that is where we're really starting to dig into, okay, here is our information about whatever that particular domain is. We've got our clusters of standards. So those clusters of standards, they may have one standard underneath them, they may have multiple standards. And again, we're talking about what is the cognitive rigor needed to be able to meet the intent of that cluster. And so the standards underneath it are going to be able to show folks and have you understand what kind of flows into having students completely understand a specific cluster. When we're looking at the math standards, this is where we're talking about what comes before, what comes after. It's really helpful for us to understand the progression. So if we're looking K-5, you can see all the different reporting categories or the different domains of math that we have and what they transition to after 5th grade. So everything that we're learning starting in kindergarten is going to those concepts build upon one another to be able to get students the knowledge and understanding that they need to be able to to reach that college and career readiness in high school. These are the New Hampshire model competencies. Annie Wallace at the Department of Education has done a really good job of showing us these vertical progressions. These competencies, we have them linked here. There's a lot of different tabs on them. This just happens to be the numbers and operations base 10 tab. So it goes from kindergarten all the way up. We just showed through second grade, but it basically shows you the progression of skills for each particular area or domain of mathematics. I can see Marissa's having a little bit of a hard time getting to exactly where they are. What we'll do is we'll make sure that that link, we wanted to send you to the Department of Ed site, but we can also set it right to where those latest and greatest competencies are as well. But what this does is that if you're a teacher and you teach second grade, take a look at these. If you're teaching specific concepts, you can see if we're looking at, MBTA, it's just understanding place value, all those different skills and understandings that students need with those standards, and then also what came before it. In math, one of the biggest things that teachers have trouble with, especially in elementary, is knowing where to start if students don't understand. So this is a really good way to be able to kind of figure out, okay, where are these students? I can meet them where they're at and really sort of scaffold a little bit and bring them up to where our grade level standards are. We always want to be teaching to our grade level standards, but knowing where they came from or where the gap might be, we can get them there faster. Another place that's super helpful for us to understand the progressions of our standards are the Achieve the Core website. We have it linked here. The general information that we have here, if you want to, sorry, Marissa. Yeah, you can open any of those if we. This is a second grade example here. So what this is showing us is the information that are the supporting clusters, or the major clusters are green. Those are like, the students need to know these in second grade. The supporting clusters are those that are also, it's not that they're not important, they're just not your major clusters. And then you have additional clusters for each grade level. This is an algebra progression. So you just need to know that. This is getting them from, these are grades K to 8, and it's getting the students ready for algebra in high school. In the past, that has been the major focus, is getting them to algebra. It doesn't mean that geometry isn't important. It doesn't mean specifically data and statistics. That's really some up and coming needs for, especially for the workforce. So right now, this is what we have for the algebra progression, but it may change as time goes on and the needs for mathematics changes a little bit as well. But these can be very helpful for understanding what you need to really focus on in each grade level. All right, on the back side of any one of the grade levels, it shows you the full progression. Again, you can see leads towards middle school algebra. So you can kind of see what's important at each grade level. Again, a game changer for teachers as they are teaching a specific grade to know what came before and what comes after. We can't really talk about math and standards of mathematics without talking about the standards for mathematical practice. These are the 8 standards across every single grade level. They are, I feel like in some respects, can be forgotten when we're teaching mathematics because we're so focused on our specific grade level standards that we forget that we really need to be able to persevere. We need to be able to do problem solving. We need to be able to reason abstractly, all of that, model with mathematics. which doesn't necessarily mean using the standard algorithm, modeling, showing how we know things. So we just wanted to make sure we're not going to talk a lot about the standards for mathematical practice today, but we wanted to make sure to include them in this presentation.
Looks like there's no questions so far, so I'm going to kick it off with some misunderstood standards. Um, what we wanted to sort of start with here is that, you know, we don't intentionally misunderstand standards. The standards, there's a lot to them, right? And so we misunderstand them sometimes not because they're difficult, but because there's a lot more to them and they are requiring students to think a lot more deeply than we initially think they are. So what you're going to see in this K-5 webinar today is a lot of the misunderstood standards does have to do with computation. Um, that was the focus area that sort of Heather showed you in the beginning slides, right? K to 2 and then 3 to 5 is that addition and subtraction, multiplication and division. So that is what comes up a lot. And that's where we see the breakdown when kids get to middle school, grades 6 to 8. So what we might think, right, is just the simple computation that we're teaching our students. What we're really trying to instill in them is, number sense that's going to carry them through to the higher grades. We're first going to talk about some general misconceptions. These are related to K to 5 math standards. Afterwards, we are going to do examples from each grade level for K to 5. So the biggest one and the one we see, when we especially like visit the schools a lot and go into classrooms is the standard algorithm. And so, what we're sort of outlining here is when the standard algorithm is actually introduced to students in the standards. So, grade 2, not introduced. Grade 3, it's not introduced. Grade 4, the standards say that students will be able to use standard algorithms to fluently add and subtract. And what we're seeing is that standard algorithm is usually, or not usually, but when it's misunderstood, it is introduced in grades even 1, 2, and 3. And there shouldn't be any sort of procedure being taught around addition and subtraction until grade 4. Grade 5 is using the standard algorithm for multiplication. And grade 6 is that standard algorithm for division. And so sometimes, we work with educators and they're sort of shocked to hear that the standard algorithm isn't introduced until so late. And so what does it really mean then when we're asking students to use place value to add and subtract? Like, what does that mean? That's the sort of deeper connections that we need students to make. And so, what we wanted to include in here is that this is a read called Fluency Without Fear by Joe Bowler. It is an amazing read. It's actually linked on the next slide, and in the folder, you'll be sent so much of the reading we wanted to put in here because it's great. But it really talks about our sort of our understanding of that word fluency in the Common Core. And what this quote is really saying, and what she is saying, is that the Common Core standards actually de-emphasize the rote memorization of math facts. However, when we hear the word fluency in the Common Core, not only us as educators, but even publishers like the textbooks that we're working with, resources we find, they sort of emphasize or encourage that rote memorization in our classrooms. And so it's not even, to our own sort of fault that we are having students do this. This is what's in our curriculums that we're teaching students. However, just because it's in our curriculum or in our textbook, we should not be viewing fluency as, speed, rote memorization, timed, um, those sorts of things. However, right, we talk about fluency that we need that procedural skills and fluency, um, because we need that speed and accuracy in our calculations, especially moving through the grade levels. So, how do we accomplish this, right? If we need procedural skills and fluency, but we are not supposed to be having students memorize their math facts, um, so we must build that procedural fluency from conceptual understanding. That conceptual understanding comes first. And so when we talk about conceptual understanding, we want to make sure that we're teaching students the concepts behind the procedures first. And so those procedures are meant for later down the road to make calculations more efficient and quick. But in order to do that, we need to have them understand conceptually first. And this one here is very true. Students often have difficulty with conceptual understanding. And so a lot of times what we see is that we're trying to get students to understand conceptually, and then we sort of jump to that procedure and we see that light bulb go off. And so we think that students are now understanding, I'm just going to put addition, for example. They're having trouble with, using models. However, we teach them a procedure and they understand it, or we perceive that they understand it, when really they're able to follow a set of steps. And so we think that light bulb has gone off, but that conceptual understanding might not be there. And so it is difficult and it is going to take time, but we can't jump to the standard algorithm just because it might be a quicker, more efficient way. So, thinking of that word fluency, this also comes from that article, is that defining fluency as knowing how a number can be composed and decomposed, and then using that information to be flexible and efficient with solving problems. And really, what we sort of emphasize here is that composing and decomposing of numbers, having that number sense, is really what we're trying to instill in students in grades K-5. Once they get to middle school, they can really fall apart if they're not able to compose and decompose numbers and understand how they work. And this is just some food for thought. We're in K-5. A lot of you who teach math also teach ELA. And so when we think about it, we can compare it, to this example, like teaches vocabulary, that we don't just give students, a lot of words to memorize and then we time them on their definitions. So we need, why do we treat math differently when it's the same thing? We learn vocabulary through, reading, speaking, listening. And so we need to do that same thing with math, as well. And we're emphasizing the math facts because that's something we hear a lot is, well, the students don't know their math facts. The students don't know their math facts. I was visiting a school 2 weeks ago, and they have across their K-5 timed math fact tests still. So we want to make sure that we are um, getting students to understand getting students to understand how numbers work in a different way, not through rote memorization. We also wanted to include the 13 rules that expire. Heather was a grade 2, and I think maybe 3 um, educator. So she's definitely all for making sure that we understand that the rules that we sometimes use in our classrooms, knowing that there is an expiration date, and that, as students progress throughout the grade levels, these no longer make sense to them. And so a part of that is that when we are first introducing, concepts to students, is that usually that first thing that they hear sticks with them. And it continues to stick with them if they're hearing it year after year. So we need to make sure that we're not teaching tips and tricks that have an expiration date. So these are some examples. The reading is linked here. It's a great read. There's some more on this slide, some of the examples, big one we hear is like using keywords to solve problems. Okay. That has an expiration date. We can no longer rely on that. We have to rely on more problem solving skills and making models about what we're reading and how we're going to progress through the problem. Things like you cannot take a bigger number from a smaller number. I think that's a big one that we always put the bigger number on top, we put the smaller number on bottom, right? We're teaching this tip and trick for our grade level, and we don't always see that that's actually not true, and that's going to hurt them later on down the road. So these are just some examples of some of the rules that expire for students. Again, that's linked here. It's a great read. It goes into a little more detail if it were to load. There we go. Um, and it also goes into, some expired language as well, and then what some alternatives can be. So if you're unsure of, how to sort of reframe your language, this is helpful to to um to read about what that language might be. And now we're going to go through some commonly misunderstood standards for each grade level. So we're going to do an example for all grade levels K-5. And so we're going to start with kindergarten. And so these are domains, counting and cardinality and number and operations in base 10 with major standards. These are the most commonly misunderstood standards in kindergarten. And so we're gonna go through three of them specifically. So these are three kindergarten standards here and their misconception. These are mostly about counting and numbers representing the quantity of objects. And so we can look through here and see that the misconceptions around, counting is just about saying numbers in order, that they don't represent a quantity of objects, or if we're counting, it's always done with the same set of objects. And these are some examples of what we're referring to there. And so we want to talk you through the progression, especially because counting and cardinality is the only domain in kindergarten. Or excuse me, I worded that incorrectly. That domain is only in kindergarten. If you remember that domain progression, it turns into numbers and operations, base 10, and numbers and operations fractions starting in grade 1. So when we think about the progression, is that students typically learn to recite counting words first before they use them to count objects. Then they become more fluent in that counting sequence and can focus on matching words, number words to specific objects. And so this source here linked can take you through this progression because we wanted to not only give you what the commonly misunderstood standard is, but also how you can learn best practice or best instructional strategies for students to take them through this progression. We also included here some tasks to deepen student understanding as just some options for you that you can do as students. And then, so we're getting to grade 1. All of the common misconceptions from grade 1 to grade 5 came from that Achieve the Core, where they really broke down what the common misconceptions were for the different standards. Again, a lot of them have to do with that focus area of K to 2 being addition and subtraction, and 3 to 5 being multiplication, mostly in division. So these domains, operations and algebraic thinking, number and operations base 10, and measurement and data, these are the most commonly misunderstood standards here. I'm obviously not going to go through all of them for timing reasons, but we are going to go through either one or two per grade level. So for grade 1, we're looking at comparing two-digit numbers based on meanings of the tens and ones digits. So some of the misconceptions here is that instruction focuses on memorizing steps or the naming property, right? So 6 times 7 equals 7 times 6 as a commutative property, rather than using what we know about the commutative property to multiply. And the other one is that students, they will apply what they know about the properties in other grade levels. So the foundational understanding of the properties is critical for later success, and that the vocabulary comes later as well. This is an example of that sort of question. This is also a common misconception about adding within 100, including a two-digit number and a one-digit number, and then adding a two-digit number and a multiple of 10. So some of the misconceptions around this standard is that the instruction and mostly that the problems students are provided with is that they're either two-digit numbers being added to a one-digit number or two-digit numbers being added to a multiple of 10. And so we're going to take you through an example of how to address this standard with some student work. The other misconception is that instruction rushes to the standard algorithm, right? So if we're adding either a two-digit and one-digit number or a two-digit number and a multiple of 10, we use place value understanding, but sometimes we assume that that means the standard algorithm when it in fact does not. We want to use concrete and pictorial representations. So this is an example of some student work around the true intention of this standard. So here, if we have 23 plus 36, right, neither of those are a multiple of 10, and neither of those are a one-digit number. But if we take a look at the reasoning that students are using, right, to break apart, right, here we're breaking apart 36 into a one-digit number and a multiple of 10, then we can see how students are able to add within 100. Same thing here, breaking up these two addends into a multiple of 10 and a one-digit number. And we can see, right, how these students are growing their number sense by decomposing and composing numbers, right, and not just using the standard algorithm. When we look at grade 2, again, just starting off with some of the most common misconceptions that there are within the standards. And so here, one of them is adding and subtracting within 1,000 using those concrete models and drawings. So what are misconceptions? Again, it focuses on procedural methods without building that conceptual understanding, and that those steps in the procedure doesn't build students' understanding of adding or subtracting like units or composing and decomposing units of tens and hundreds. So when we think about some instructional strategies, again, the source is linked here. So if you want to read further into what we have here, is that we want to make sure that we are composing and decomposing into base 10 units. We can use drawings, we can use manipulatives, and then we can see that these are used as like each 100 is used as a single unit rather than 10 tens. So again, we're composing and we're decomposing either in our drawing or using manipulatives. For grade 3, these are our domains with major standards. A lot of number and operations fractions. And so here we're looking at applying properties of operations as strategies to multiply and divide. So some misconceptions we have here is that students, they're going to apply what they know about properties in the other grade levels. So the foundational understanding of the properties is critical for later success. So here we're looking at arrays. And so when we think about, the roles of the factors, they do not differ. Um, One factor is telling us the number of rows, and the other factor tells us the number of columns. And so what's happening is the rows and columns depend on the orientation of the array. And so if it's rotated 90 degrees, the rows become columns and the columns become rows. So this is how we're able to sort of introduce and show the use, the commutative property for multiplication and for those rectangular arrays into areas. So if we look into this source, and it is a deep one. I apologize, I forget what page it's on, but we're able to see the progression of this standard. And so here we can see the unknown product, the group size is unknown, and then the number of groups that are unknown. And so if I go back, um, thinking about those properties, we want to make sure that we're introducing the concept right before that vocabulary. Here we have grade 4. It's getting a little heavier in the fractions, numbers and operations base 10, and operations and algebraic thinking as the standards become more complex. So here we're looking into multiplying a whole number of up to 4 digits by a 1-digit whole number, and then multiplying two-digit numbers using strategies based on place value and the properties of operations. So the most common misconceptions here is that, again, instruction focuses on that standard algorithm for multi-digit multiplication. When we think about the connections to place value, the distributive property, and models used to represent the multiplication, they're not made by students or they're not made at all. So we're not having students use, you know, or build their own models to represent the relationship or how we do multiply whole numbers, and that sometimes instruction will focus on 2 by 2 digit first instead of that 4 digit by 1 digit. Another common misconception is finding whole number quotients and remainders using strategies based on place value. Again, focusing on that standard algorithm is a common misconception, and that connections to place value, multiplication, and properties in the models used to represent the division are not made by students. So again, some common misconceptions for both standards here. And I think that word, um, the models being used. I was working with a school who was doing the standard algorithm in grade 5 for division. And the task had asked the students to use models. And we were looking at student work, and all students were using the standard algorithm. And so it brought up this conversation around, well, is the standard algorithm, is that a model? And there was definitely some debate back and forth where some, educators thought that it was a model and some did not. So this is where we can have those conversations around students being able to use models, right? The standard algorithm is a set of steps. It's not a model that's representing their thinking. And so it's important that we have students using models. Sometimes we think that goes away as we get into the upper grades, but it's still a critical piece for student thinking. Also, with manipulatives, we see those sort of move to the wayside as well as students get through the grade levels, but we need to make sure that those are still options for students. So when we think about instructional strategies, right, what does it mean for students to be drawing their own models or using models? So we have 3 examples here, right? If we have 10 times 30, having students represented three tens, each taken 10 times. Here is another model of partial products. And the last model is illustrating those partial products with an area model. So sometimes it's hard when we're looking at the standards and again, thinking about place value or whatever sort of area model might be in this standard, we can sometimes wonder exactly what that means or what that looks like. So again, this link here is going to sort of take you through, what does it look like then for students if they're not using procedures? And lastly, we have the grade 5 most common misconceptions here for number and operations fractions and number and operations in base 10. So we're looking at applying and extending previous understandings of multiplication to multiply a fraction or whole number by a fraction. So instruction might be limited to steps in a procedure, or we might be missing from instruction the use of those concrete manipulatives or drawings, which we need to demonstrate the multiplication of proper fractions as taking a fraction of a fraction. So, especially we all know students struggle with fractions and their understanding of fractions. And so we need to make sure, right, that we're not just multiplying our numerators or multiplying our denominators, that we're actually having students make models or use manipulatives to understand why we are doing that procedure eventually. The other greatest misconception is the addition, subtraction, multiplication, and division of decimals. Instruction, again, is focused on steps to follow for completion, and that students aren't applying what they know about place value in the area model from fourth grade as they begin to explore that decimal multiplication. So this is where, when the standards are sort of progressing, that fourth grade introduction of the area model and place value is critical for students in fifth grade. So if they don't have that in fourth grade, then when students get to fifth grade, they're still going to struggle. This standard has a lot to it. We're adding, subtracting, multiplying, and dividing decimals to hundredths. That, if we were to unpack that, that is a lot for students. So we need to make sure that students are getting what they need in the previous grade levels to be able to come here and use those models. This is sometimes why I think teachers or educators in the classroom sometimes jump to the procedures because there's so much to it, and that procedure is that sort of quick fix for students to follow. And we need to not jump to that quick fix. We need to make sure that we are still pushing students to think more deeply about what it means to add, subtract, multiply, and divide. So here's an example of some instructional strategies about what we're talking about when we ask here for students to use models or concrete manipulatives. This is what we're asking students to be able to draw and understand. So this model represents a half times 3/4, and these represent a half times 3/4 as well, just drawing two different models. So we want students to be able to visualize it and understand it conceptually first. As you can see, there was no multiplying numerators and denominators. We are showing visually what it means to take a half of 3/4.
There aren't any other questions there. Thanks, Marissa. All right, so now what we want to talk about is overcoming other misconceptions. So Marissa just went over all of the common misconceptions for grades K-5. Those are the biggies. But what ends up happening is you get back to your classroom, and yes, we want you to focus on the big ones because those are the ones that are are really sort of making things harder for your upper grade levels as we go through if we're misunderstanding at the earlier grade levels. But we want to show you a little bit of how you can, with either yourself or with a group of teachers or what have you, coaches, whatever, be able to kind of unpack and really understand what the intent of the standards are. The biggest thing is that unfortunately, it is us, the educators, that are the where those misconceptions begin. Marissa talked about it a little bit earlier. Yes, I used to teach younger grade levels, second grade, addition and subtraction with and without regrouping and related to place value. My initial thought for that and the way I taught it for a long time in my career was I lined it up. It's place value. You line them up, right? Then what that does is it lends into the traditional algorithm, and we don't necessarily want to be doing that. So here's a few slides that we have to kind of help you with that. The first things first is deepening our understanding of what the standards are. Um, Marissa and I always joke when we're on site or do any sort of trainings. I have never met a teacher that's like, ugh, I don't really know my standards. We all feel like we know our standards, or at least in some way, shape, or form. Or sometimes we feel like we know it because we have a math program, and the math program, it's standards aligned, it's Common Core aligned, we're good. But we need to be thinking about it a little bit more as educators of where we want to go with this. So the first things first, this we want to identify those key concepts, right? What are the key concepts for this particular standard? We can unpack that so that we understand what the knowledge and skills need to be for that particular standard. And then we also need to be thinking about what is the level of mastery are we talking about? What is that depth of knowledge that we're talking about across each grade level? So, as we unpack standards, there's sort of three steps that we have. And first is to isolate those key words in the standards, help us understand again the critical content and skills needed. The next thing is looking for links between the standards and that overarching cluster, right? So we have our cluster. Sometimes, again, one standard's underneath it, and sometimes you have three. So those three standards are related to one another. They need to do those three things to be able to do what that cluster is asking us to do. So we need to understand that what the full understanding of that particular cluster is. And then whether you turn them into I can statements or student success criteria or however you want to word it for what makes sense in your school, it needs to be in some sort of student-friendly language for as low as kindergarten. They need to understand what they need to know. When they know what they need to know and see where they're going, it's going to make a world of difference. So on this next slide, we have, this is the outline. This is a template. We've linked the template here. Um, Again, we're overcoming some of these misconceptions. That template can turn into something like this. Here's an example of that numbers and operations based 10 standard for fourth grade. We're talking about multiplying a whole number. You've got all the information up here at the top. We've kind of highlighted some of the keywords, right? We're going to multiply with whole numbers. We're going to illustrate and explain the calculation that we're doing, and basically using equations, rectangular arrays, or area models. First things first, we get those verbs, right? We get the nouns and adjectives out of there. Then we start to break it down into those skills, right? What do they need? They need multi-digit multiplication. They need to understand how to use drawings and different strategies, what knowledge they're going to need, and then that understanding that they're going to need. And then that sort of the next one over the orange is what are they going to be able to do? What do they need to know? And how will we know that they understand, right? What do they need to understand to be able to do this? Now, this seems like a lot, but what ends up happening is you start to understand a little bit more of the intent of a standard and looking at the whole standard, because sometimes we just look at part of it. right? Fifth grade, looking at a standard where you're rounding numbers. Oh, great. We can teach kids. They can round to the nearest 10, they can round to the nearest 100, to the nearest 1,000. We got them. But the standard actually says that they understand rounding, so they should be able to say, if I'm rounding to the nearest 10, I should know what is the range of numbers that will round to the number, let's say 20. Well, what numbers round to 20? That's different than just saying round 17 to the nearest 10. So we want to be able to kind of pull out that understanding and knowledge. We had a whole unpacking standards webinar. This is that link. It gives you a lot more information and a few more examples. It also gives you ELA examples. It wasn't just math, but we just wanted to link it here so that if you were curious about understanding a little bit more, the webinar that we did is here. Another way for teachers, starting really in grade 3, because these are the New Hampshire SAS, what are called performance level descriptors. And what those are is we've linked all of them up to grade 8. They basically show us each standard, and then it shows us what a student who is a level 1 student, so a below proficient, a level 2 student who is approaching proficient, and then the level 3, which is proficient, and then the level 4 is highly proficient. This is really helpful for teachers, specifically for you folks today in grades 3 through 5, because you can look at any standard and look at what those different students are doing at the different proficiency levels to say, oh my gosh, I'm teaching to actually the performance level 2 student, which means this is why my kids are not necessarily doing everything that they need to be doing with the standard to be able to do well on assessments and to get to the next grade level. So these can be really super helpful when looking at depth of knowledge. Sorry for our K-2 folks, they are New Hampshire SAS ones, so they are grade 3 or higher. This next slide gives us a little bit more of, looking at and addressing those misconceptions through depth of knowledge. We just used the specific standard, a measurement and data standard that's, recognize area as an attribute of plane figures and understand concepts of area measurement. So again, the common misunderstanding is students are finding the area by counting squares or using length times width. But the true intent, or a DOK3, would mean that the students are able to reason and understand why that formula works, and they're able to decompose and recompose shapes that maintain the same amount of area. It's not just counting, it's not just doing that sort of procedural portion of it. And then there's a task example that we have down there where you could use two rectangles with the same area. Some of the last things we want you to think about is, okay, so let's say now we're on it. We know what the misconceptions are. We're taking a look at our standards. We're unpacking those that we think we might have some challenges and understanding with. Then what we need to do is then carry that through other portions of what we do in our classrooms to see where students are with their learning. And that's now looking at assessments, right? We want to make sure that you're reviewing your assessment tools and what your assessments are. You may be using a program and you may be required to use those, but just make sure you're understanding what are we actually assessing? Are we assessing what we feel like we need to assess? And do we need to tweak some things? You want to also think about that backwards design. Even if you have a program, at least think about, rather than turning the page, at least think about where are students supposed to be at the end of this unit? So, okay, here's where I want them at the end. And every day that you are teaching, part of your scope and sequence, remember what the end game is and how you need to get your students to where that end game is. It will help you, just maintain that continuity. And it also helps students understand where they're going. So we want to be able to then check for those gaps or any misalignments as we're moving through our unit. And in doing that, sort of the next slide is going to feed it into that. We're looking a lot at formative assessments, right? We don't just assess at the end, but how are my students doing on a daily basis? Am I taking a look at sort of how they're doing, where any misconceptions might be? What can I look at to help inform my instruction? So figure out, where am I going? Where am I now? What do I need to do next? All that formative assessment can help us understand where students are in relation to our grade level standards. So just a little bit of, I guess, thoughts about how formative assessments can uncover misunderstandings for students, right? We want to aim for questions or responses to reveal how students think, not just what they remember. Again, it's not just show me, like the answer to this. There are many times where we don't really care what the answer is. We care about your thinking and how you got there. That's building that conceptual understanding. You want to encourage explanations and demonstrations, even for students that you feel are quote unquote high, right? Like, oh, they already know how to do that. Or they say, I just know. I'm going to tell you, the I just know kids in kindergarten, first, second, third grade are going to be the what in the world is happening kids in the fourth grade, fifth grade, sixth grade, and beyond, because they aren't going to have that flexibility in a lot of cases. Now, some kids will. You could teach them the traditional algorithm and they can do math all day long. But for the most part, those kids that say, I just know, are the kids that are not going to necessarily do well later on. So continue with those explanations and demonstrations. The prompts that can show flawed thinking, it's great to be able to have misconceptions. You can even do specific activities that have an incorrect answer to something, and it shows a quote unquote child's thinking, and tell me where the thinking broke down with this, so that you can use all of this information to figure out and make sure there aren't misconceptions with their thinking. Again, making sure that you're targeting the most important concept or skill from a lesson. Student reflection is key to this process for you to understand where they are. And again, it doesn't have to be a lot. They can be really short. They can just make sure you're aiming at, how am I going to ask my questions, or what can I do to be able to really get to the meat of what students know and where their thinking may break down. This is our little roadmap and sort of the wrap up of the overcoming misconceptions here. And just reminding you that your understanding of the standards, um, and understanding and knowing what to teach is going to be able to help your students think more deeply along the way. And those misconceptions will be few and far between as you continue to move through the grade levels.
I don't see any questions, so we're just gonna take the last minute or so to wrap up. We wanted to include some links here to help you understand your standards in even more depth. So a few of these, the Robert Kaplinski depth of knowledge matrices, the Lexile Quantile Hub are just two out of these resources here that can definitely be helpful in looking more deeply into your standards. Adding that the Lexile Quantile Hub is free for New Hampshire educators. So that is also sponsored by the department. So if you don't have an account or login, it is free to make one. And then we have, if you are interested in some K to 8 excuse me, 6 to 8 commonly misunderstood standards webinar. We are doing that tomorrow if you want to sort of follow the progression here. And also for ELA K-5, that's in the beginning of December, December 9th, for those standards there. And so again, when you log out, you will, or exit out of the webinar, you will get a short survey. We'd love your feedback, especially we're doing this webinar tomorrow and 2 more times in December. So please let us know some feedback, and we're always looking to improve these for you in the field. And here's our emails and information. If you have any questions, please reach out to us, especially if you had a specific question, we were unable to answer it today, or we didn't go through it today. We would love to hear from you about anything you may need. So thank you so much, and we appreciate you coming.